Good afternoon. Before already I have uploaded a video regarding semiconductor then doping in that. So today we'll go with certain devices in which we'll try to understand the formation of PN junction. So to understand the formation of PN junction, what we have to do is we have to take P-type crystals and N-type crystals. So when we are taking P-type crystals and N-type crystals and they are as contact state to each other, they are assembled as a single piece, then we say as PN junction diode, we can say it as. So let us see with a certain diagram. Suppose now what happened is in P section it has the maximum hole carriers and in N section it has maximum electron carriers. Now due to the high concentration in this, so the holes tries to diffuse, it diffuses, it gets diffuses towards N section, and from N section the electron gets diffuses. So while diffusing, okay, they come in contact with each other and they cancel out their effect to form a layer. That layer is said to be what? Depletion layer. Which is of width 10 to the power of minus 6 meter. After that, so when they form in this way, then what happens? Say that they no longer remain neutral. So ultimately when the holes gets diffuses towards the N section and electrons gets diffuses towards the P section, the holes when it gets diffuses to the N section, that means what? It becomes slightly negative charge towards the junction. And when the electrons, that is, it gets diffuses towards the P section, then maximum it gets positive charge over near the junction, forming a kind of battery. So due to diffusion of holes from P section to N section and the diffusion of electrons from the N section to the P section, so they no longer remains neutral. So finally what happens? So here it becomes slightly negative charge and here it becomes a slightly positive charge. It seems as if it is some fictitious battery is set up. So finally what happens? It becomes a potential barrier. Once it becomes a potential, here it becomes a potential barrier of, for the silicon it is 0.7 V. So once it becomes a potential barrier, it obstructs the diffusion of holes and electrons from the P section and from the N section. So when there is a completely set up of potential barrier, a high electric field is also set up. So to calculate the electric field, we know that E is equals to V by L, where L is the length and V is the potential. We get here 0.7 by, and the depletion layer was of 10 to the power of minus 6. So we get here 0.7 into 10 to the power of 6. That is the electric field we are getting. That is V per meter. Thank you. If you have further more doubt regarding this junction diode, you can just put your doubts in my comment box.